All right, welcome. In this video, we're going to do an overview of the different types of chemical bonds. And the bonds are the attractions that hold atoms together within a sample. And there's different types of bonds. The main types we'll look at are ionic, covalent, and metallic bonding. And you can have bonding in a sample of a pure element. So like if you have a sample of pure carbon, those carbon atoms are going to experience network covalent bonding. If you have pure oxygen, those oxygen atoms are going to bond together in something known as molecules. So it's going to experience molecular covalent bonding. If you have pure iron, it's going to experience metallic bonding. So you can have it in pure elements. And you can also have bonding in compounds. And the type of bonding you see in compounds is going to depend upon the types of substances involved in the compound. So if you have two or more nonmetals combining, so like carbon and oxygen, hydrogen and oxygen, carbon and hydrogen, then you will form typically molecular covalent bonding. And if you have a nonmetal plus a metal, then you will have ionic bonding. So some examples of that would be like table salt. This is what you put on your food, is sodium, which is a metal, and chlorine, which is a nonmetal. Epsom salt is made of magnesium, sulfur, and oxygen. So we've got a metal plus some nonmetals. Baking soda has metals and nonmetals. And remember when you were trying to figure out, who's a metal versus a nonmetal, you were looking at your periodic table. And the metals are over here on the left. The nonmetals are up there on the right. And then hydrogen's the odd one. It is also a nonmetal, even though it shows up here on the left side of the table. So those are your nonmetals. Cool. And these over here are your metals. So be using your periodic table when you're trying to figure out the bond type. Here's another summary of this one. So again, ionic bonding occurs between metals and nonmetals. Okay, those are the types of atoms involved. Whoops, right here, metal and nonmetal. We call that ionic bonding. And then what happens with these different types of bonds is electrons are doing different things. So bonding always involves electrons, but in the different types of bonds, electrons have different roles in that bonding. So in an ionic bond, the electrons are transferred. When what we mean by transferred is that like one atom gives up electrons, the other atom takes those electrons. So there's some like give and take there with ionic bonding. In covalent bonding, they occur between two or more nonmetals, and they share those electrons. So they both are hanging onto those same, both atoms are hanging onto those same electrons, and they're sharing them. And then when you have metallic bonding, the electrons are pooled together. So it's like every atom jumps in there and kind of pitches in their valence electrons, this big pool that are just loosely shared everywhere amongst all the atoms. So that's metallic bonding. And here's a visual showing these different types of bonds. And in this visual, the blue shaded area represents the valence electrons. And so notice that in the metallic bonding, they're just kind of a big smear of valence electrons everywhere. In molecular covalent, those electrons are just in between pairs of atoms, so they're being shared amongst these pairs of atoms. Over here in network covalent, they're being shared just everywhere between all the different atoms there. Okay. And then in ionic, you say there's no sharing. There's some atoms have the electrons and some don't. So that's what we mean by a transfer of electrons. So what happened here is that these atoms gave up their valence electrons to these atoms over here. Okay, and that's ionic bonding. So we're going to dig into this in more detail. So in ionic bonding, well, first of all, let's identify what an ion is. So an ion is just a particle with a charge. So it's an atom that has a charge. And what happens in ionic bonding is that the metals give up their valence electrons to the nonmetals. So this atom would represent a metal, this would represent a nonmetal. As a result, you end up with positive and negative ions. So the metals lose electrons, they become positive. The nonmetals gain electrons, they become negative. And then opposites attract. So what's holding them together is just the attraction between these oppositely charged ions here. And that's what an ionic bond is. And with ionic compounds, they tend to form these nice, crystalline structures. And that's because they will organize themselves naturally into this nice organized crystal lattice. So that's what ionic compounds do. We don't want to use the word molecule with ionic compounds. There's no such thing as a ionic molecule. That doesn't exist. They don't form molecules, they form this crystal lattice. We'll talk about what a molecule is in a moment. Okay, so again, here's a summary of what's going on in ionic bonds. The metals are over here on the left-hand side. This is a prettier version than what I drew a moment ago. The nonmetals are on the upper right. The metals are going to lose electrons. The nonmetals will gain electrons. As a result, you end up with a positive cation and a negative anion, and then opposites attract. So when we say opposite charges attract, that's known as an electrostatic attraction. We don't need to worry so much about that vocab word, but just so you know, that's what that is. And here's some vocab, which you should know though. Anion is a negative ion. Cation is a positive ion. And one way that people find helpful to remember cation versus anion is this saying, cations are positive. So you can think like cat paws. So if that helps you, there you go. The other way that I remember that cations are positive is if you write out the word cation. You see how the T looks like a plus sign? So to me, that's how I remember that cations are positive, is by that trick there. Okay, so what are molecules here? I just said ionic compounds are not molecules. So what are molecules? So molecules are these groups of atoms that are sharing electrons. So this picture shows 8 separate molecules here. Okay. And some examples of things that are molecular covalent would be sugar, vinegar, acetone, methane. Those are all molecular covalent compounds. And here's a picture of a water molecule. So it is molecular covalent. And you kind of get a visual of what we mean by sharing electrons. So you see how the electrons in the shells, there's like an overlap between these shells here. So like this electron right here is kind of simultaneously existing in oxygen shell and hydrogen shell at the same time. So that's what we mean by sharing electrons here in this covalent bonding. Network covalent is when you have electrons being shared, but they don't form separate molecules. They're just all the atoms are bonded to all the other atoms in this big network. And that results in substances that are really hard and have a very high melting point, such as diamond. So here's the main 3 examples of network covalent to know. So if you have pure carbon, pure silicon, or silicon dioxide, those known as quartz, those are all network covalent bonding. Any other combination of nonmetals, we're going to assume is molecular covalent. Okay, so 2 types of covalent bonds here. And here is a visual from our text that I like, which kind of relates what the electrons are doing to properties we might observe. And so ionic substances, because these electrons are transferred from one atom to the other, it can result in them being really brittle, and they can kind of like fracture along the planes of atoms there. Versus metallic substances, which we'll talk about in a moment, they are just sharing their electrons evenly everywhere. That makes them very bendable, and they can you can move them around. And that's why, like copper wire is easy to bend, is because of that metallic bonding in here. Molecular covalent substances, they tend to have relatively low melting points because they don't have bonds holding the individual molecules together. So they tend to break apart really easily. And then these network covalents tend to have really high melting points, be very hard, difficult to break, like diamond is a classic example of network covalent. So metallic bonding, So what's going on in metallic bonding is people use different names to describe what's going on here. So they talked about the electrons being pooled between all the atoms. Sometimes they call them a sea of electrons. But what's going on here in metallic bonding is that those valence electrons are not locked into any one location. They're just moving freely throughout the whole sample. And this is what allows metals to conduct electricity. So when you have electricity, is just a flow of electrons. And so in metal substances, there's electrons just moving freely throughout the whole sample. And so metals can conduct electricity in the solid form, unlike the other types of bonds we see. And with metals, you can have pure metals, such as pure calcium, pure aluminum, but a lot of the metals you're familiar with are actually found in mixtures known as alloys. So like stainless steel, brass, bronze, those are all alloys, mixtures of metals. All right, and so we can talk about the various properties that substances will have based on their bond types. So we'll notice, for example, that ionic and molecular covalent substances will often dissolve in water, whereas metallic and network covalent substances will not dissolve in water. And here's a kind of visual showing what's going on here. We can see why molecular covalent substances might dissolve in water easily. It's because there's no bonds holding those individual molecules together, so it's easier for them to break apart. And there's kind of a similar thing going on here with your ions. They can split apart into these separate ions, and the water molecules can kind of get in there in between the ions. And we'll talk about solubility more in a later unit. And the other thing we will observe with another property we'll observe is that if you have an ionic compound and you stick it in water, it will actually conduct electricity. And that's because when it dissolves, it's going to break apart into these individual ions, and ions have charge. And if you have a sample that has charged particles that can move around freely, then it can conduct electricity. So solutions containing ionic compounds, like salt water, they will conduct electricity. And that's something we observed in that lab. Metals, we mentioned this already, they conduct electricity because they have these electrons that are all moving around freely in the sample. So as long as you have charged particles that can move around freely, then you will be able to conduct electricity. Melting point, so this is another property we can observe, and substances that have low melting points have weaker forces holding them together. Substances with high melting points have stronger forces holding them together. And based on what we saw in the lab, we noticed that your ionic compounds tend to have higher melting points, whereas your molecular covalent tend to have lower melting points. And if we look back at this visual again, the reason why our molecular covalent substances have low melting points is because there's no bonds connecting the molecules, right? So we have these kind of separate molecules that are not connected together by bonds. So these molecules become relatively easier to like break apart from each other. There's obviously something attracting them together because they're still kind of sticking together in your sample, like your sample of water. All your water molecules are hanging out near each other. So something's attracting them together. It's just not a bond. It's actually something known as an intermolecular force. And that is something we will talk about in a later unit. Another thing that we might observe is something called volatility. So volatility has to do with how easily a substance will, vaporize, so turn into a gas. Okay, so evaporate means like turning from a liquid into a gas. And one way in which you can test if something's volatile is you can smell it. So substances which are smelly are volatile. That means they evaporate easily and can kind of go up into your nose there. So if you think of some examples of volatile substances, some things that you might be familiar with would maybe be like acetone, which is in, nail polish remover. And acetone is molecular covalent. And the reason why molecular covalent substances are really volatile is, again, because there's no bonds connecting those molecules together. So these can separate apart relatively easily and, travel up to your nose where you can smell them. All right. So thanks for watching this video. Hope this helped with bond types.